Hello, welcome. Let's try to solve another Leetcode problem 169, majority element. So we are given an array of nums of size n, and we need to return the majority element. And the major element is the element that appears more than 2 to the 2 divided by 2 with a floor times. You may assume that the majority element always exists in the array. Yeah, and so for this example, we know that the majority element is 3, and n is 3 divided by 2. We're gonna choose a floor. It's gonna be 1. It means more than one time. It must be 2. Yeah, and this meets the majority element. And for this example, we know that there are 4 2 and 3 1, so the majority element must be 2. Yeah, and could we solve the problem in linear time and in O1 space? If we use actual space, we can use a hash table. Of course, we can do that, but we cannot use actual space. So in this example, I'm going to use the O1 space and On time. So this is why we're going to use the Morse voting algorithm. So the algorithm is like this. So for this example, if we have an array of 3 to 3, what are we going to do? We're going to always imagine there is a majority element. So for example, for the first number, we're gonna think this is 3 gonna be the major element. It's gonna be 3. And then for the next, and we also need a counter, and the counter is 1. Yeah, we just needed to use 2 variables to solve the problem. Yeah, so for the first number, we have a 3 is the majority element, and the counter is 1. And for the second element, as this 2 is not equal to the major element. Yeah, this 2 is not equal to majority element, not equal to 3. So this is 3. Yeah, if it is not equal, so the counter would be -1. So 1 minus 1 is 0. And then we are going to check the counter. If the counter is 0, so the majority element becomes 2. Yeah, and the counter updated to 1. So this 1 means the majority element is 2, and there's 1 element for this 2. Yeah, and then we're gonna check the last element. So as this 3 is not equal to 2, yeah, because currently the counter is 1, and this 3 is not equal to 2. So we're gonna use the counter. The counter should be -1, and the counter would become 0. Yeah, so if the counter becomes 0, we're gonna update the majority element. It's gonna be 3, and the counter would be 1. Yeah. So finally, we're gonna return this majority element. Yeah, the voting system is that if there are majority element like this 3, so after one loop, we can always find the majority element. Yeah, this is like if we find 3, if we find another element, so we're gonna delete all those elements, and we're gonna search again, and now we have a 3, so we're gonna return 3. Yeah. Now let's try to code it up. So we're gonna use a major element, and we're gonna use a count. Let me set the major element as 0 because it doesn't matter. Yeah, let's just set a major element. Now we're gonna loop through the nums. So for n in nums, so if count, so for n in nums, if count equal to 0, we're gonna set the major element should it be equal to n, and we're gonna set a count should equal to 1. It means this number n has a count of 1 if this count equal to 0. So this is just like from the beginning. Now we're gonna check if major equals to this element or not. Yeah, so elif is for if count not equal to 0, so we're gonna check the major element. If the major element equal to this number, so we should know that the count should plus 1 because we have more this major element. If it is not equal, so the count would be -1. Finally, we just need to return this major element. Yeah. The code is not so difficult, but the idea is that if you didn't solve this problem before, normally you cannot think about how to solve it like this way because this is the Morse voting algorithm. Yeah, normally you can try to find a way of use the actual memory. But if you want to use O1 space, it's going to be a little bit difficult. Now let me run it. As you can see, it works. Now let me submit it to SAC if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. See you next time.